Hello, advanced algebra students. Miss Corrigan here. Welcome back. I hope you had a great spring break. I hope you were able to enjoy some rest and some time away from school. And I hope you got to get out and enjoy the beautiful weather we had here in Minnesota. Unless you were fortunate enough to be able to go somewhere fun and exciting and warm, I hope you had safe travels. Anyway, we're back, and we just have a couple short months left of school. Well, a little over 2 months, but it'll go pretty quick. I know this year in some ways has seemed really long, but it's also gone by fairly quickly, and the last 2.5 months will go pretty quick as well. We're in hybrid again this week for one more week. Next week we transition to either full in person or full distance, whichever you've chosen to do. So I'm sure you'll hear this throughout the week, but the only major change in the schedule is that instead of doing 1-3-5 on Monday, Tuesday, and 2-4-6 on Wednesday, Thursday, we're going to transition to, it's still going to be block scheduling, but you're going to do 1-3-5 on Monday and Wednesday, and then 2-4-6 on Tuesday, Thursday. So we'll keep reminding you of that throughout the week. Just a heads up that that's going to be coming next week, a little change in the schedule, okay? So we tested on the first half of Unit 9 before break, and so we're going to continue on and move to the second half of Unit 9 in probability. This one, we just have a little less than half the unit left. We got through most of it before break, but we're going to do the second half now. So today what we're going to be working on, let's see, is down here. We're just going to be doing permutations today. We're also going to be learning about the fundamental counting principle. Okay, so these are all the targets for the entire unit, but today specifically, we're going to calculate permutations. We're going to use the fundamental counting principle to count permutations, and we're also going to simplify expressions with factorial notation. Alrighty. So to start, you want to take some notes. There's some vocab that we'll learn. The fundamental counting principle is what we'll start with. This is a rule used to count the total number of possible outcomes, okay? Basically, what you're doing is if there's n ways to do one thing and m ways to do another, then you have n times n ways to perform both of these actions. So basically, you're choosing an option for n and an option for m. And remember, when we see that word and, in probability, that implies that we're using multiplication. Okay, so we're going to multiply those together. All right. Before what we did, this is a shortcut to the tree diagram. So we learned the tree diagram before. So for example, you don't have to write this down, but if you want to, you can. What we did before, I'm just going to show you how this relates to what we did the first half of the unit. We would draw out a tree diagram. So if we had to put an outfit together, and you have 4 shirts and 3 pairs of pants, how many outfits can you make? What we did before is we would draw a tree diagram. So you'd have shirt 1, shirt 2, shirt 3, and shirt 4. And then from there, you could pick 3 different pairs of pants. So you would say from shirt 1, you could pick pant 1, or you could pick pant 2, or you could pick pant 3. And then you would do that for each option. And at the end, that would be your total number of outcomes. You'd have an outcome here, an outcome here. You could pick shirt 1, pant 1. You could pick shirt 1, pant 2. And then you would count up the total number of possible outcomes you would have. But like we talked about before, drawing out a tree diagram is not always super realistic because it takes a lot of time, especially the more options you have, the bigger the diagram gets. And it just gets kind of complicated. So the shortcut to doing that is called the fundamental counting principle. If you have 4 shirts, okay, so you have 4 shirts and you have 3 pairs of pants, 3 pants, the shortcut way is to say, well, I have 4 choices for my shirts and in probability is multiplication, and I have 3 pairs for pants. So to find the total number of possible outcomes using 4 shirts and 3 pants, we would just multiply those 2 together. So we'd have 12 total possible outcomes. Okay, and that's what you would find is if you drew out this whole tree diagram, well, here's one outcome, here's another possible outcome, here's another possible outcome, and so on, and you would see there'd end up being 12 total possible outcomes. So the shortcut to drawing a tree diagram is to see how many options you have for each independent event, and you multiply them together to get the total number of possible outcomes. Okay, well, suppose you have more than 2 events happening. So there's n sub 1 ways to make a choice, n sub 2 ways to make another choice, n sub 3 ways to make a third choice, and so on. Okay, so before we just had 2 different independent events happening and we want to see the total number of possible outcomes. Well, you can have more than 2, but to find the total number of possible outcomes, you're just going to multiply all of those independent events together. Okay, so it would be n sub 1 times n sub 2 times n sub 3 and so on. Okay, so for example, excuse me, if you have 6 different textbooks in your backpack, how many different ways could you line these up in your locker? All right, so I have 6 textbooks. I can draw out a little diagram too, sometimes that helps me. So I have 6 textbooks. I have textbook 1 here, I have textbook 2 here, 3, 4, 5, and 6. I'm going to line all those up. Well, there's 6 different options I could pick from for the first book. So I could pick any one of those 6 here. I could put them here. And then I have 5 books left to pick from to put in that second spot. And then, remember, every time we hear that word and in probability, it's multiplication. I have 4 books left to put in that third spot and 3 books left to put in the fourth spot, 2 in the fifth spot, and then I have 1 book left for that last spot. So to find the total number of ways I could line these up or order them or arrange them in my locker is going to be 6 times 5 times 4 times 3 times 2 times 1. And if I multiply all those together, I get 720, which kind of seems crazy that if you have 6 books, you could arrange them in 720 different ways. So imagine drawing a tree diagram out for that. That wouldn't be very fun. So this is your shortcut to a tree diagram. So it's called the fundamental counting principle. It gives you the total number of possible outcomes that you can arrange a set of items. Okay, so for another example, let's say you flip a coin 4 times. How many possible outcomes are there? Okay, well, again, I could draw this out a little bit to help me organize my thoughts. So I'm going to flip a coin. I know I'm going to flip it 4 times. Okay, so I'm going to flip this coin 4 times. How many possible outcomes? Well, if I flip a coin the first time, I'm either going to get heads or tails. So I have 2 possible outcomes for that first coin flip. And then, multiplication, I'm going to flip it again. Well, it doesn't matter what I got the first time. I still have 2 possible outcomes for the second one, either heads or a tails. And then I'm going to flip it a third time. I'm either going to get heads or tails. And then I'm going to flip it a 4th time and get either heads or tails. So unlike the previous example, where once I put a book in the locker, I'm not going to use that book again because I'm putting it in a certain order. So I don't have that book to pick from again. I'm putting it in an order. This one, when we're flipping a coin, you flip it, and then you still have that same coin. You're going to flip it again, and then you're going to flip it again. So you want to try and think about like what happens. Okay, so for the first one, I put a book in place, and I didn't reuse it. Okay, so that's why I only had 5 left to pick from, and then 4, and then 3. But when I flip a coin, I'm going to flip it, and it's independent of what happened the first time. I'm going to flip it again. I still have 2 options. So I'm going to multiply all those together, 2 times 2 times 2 times 2. And I have 16 total possible outcomes. Okay, moving on. So that was fundamental counting principle. Moving on, we're going to talk about factorial. What factorial is, it's the product of all positive integers less than or equal to n. So just like everything in math, the definitions sometimes are kind of confusing, but when you put it into action or into words or into a problem, it makes more sense. Okay, factorial is denoted by this exclamation point. Okay. Oops. All right, so whenever you see this exclamation point after a number, that represents factorial. And you have it in your calculator or on your phone. You're going to see an exclamation point. You may have never used this before, but you can search for it. You can put in a number and type factorial, and it will evaluate factorial. However, just like when you learned how to add and multiply and divide, you need to know the process behind it in order to understand why it's doing what it's doing. Okay. So we're going to first write this out in expanded form, because you can just type this in your calculator. 4 factorial, it'll give you an answer. But we want to understand why that's happening, or what it's doing to get you to that answer. Okay. So we're going to start by writing this in expanded form. So factorial, 4 factorial means you're going to start with 4. So that would be our n. And then we're going to multiply it times n minus 1, which is 3. Or multiply it times n minus 2, or n, which is 4 minus 2, or 2. And then all the way down to 1. We don't go any less than that because it's the product of all positive integers. Okay. So it's the product, multiplication of all positive integers less than or equal to n. So in this case, our n was 4. And then we keep going down and down and down until we get to 1. And then we stop. We don't want to multiply it by 0 because that's just going to be 0. We're not going to do negative because it just says positive integers. So 4 factorial is 4 times 3 times 2 times 1, which is 24. Okay. Our next example, we're going to write 6 factorial divided by 2 factorial in expanded form, and then we're going to evaluate it. So we have 6 factorial. So our n this time is 6, and we're just going to multiply it. It's a product of all the positive integers less than or equal to that number, divided by 2 factorial. And I'm going to line this up right here because we're going to use that as a shortcut in the future. Okay. So a couple different things you can do here. You can evaluate this all the way out. You can do 6 times 5 times 4 times 3 times 2 times 1, and then divide that by 2 times 1. Or you can say, well, I know my 2 times, so this would be expanded form. But to evaluate it, the shortcut to evaluating it is, well, I know 2 divided by 2 is going to go away, and 1 divided by 1 is going to go away. So then I can just do, in my calculator, 6 times 5 times 4 times 3 times 2 times 1. Or I'm sorry, 6 times 5 times 4 times 3, which is 360. Okay, so again, you can put this in your calculator and check it or double check it or see if it's right, but you are going to have to know how to write these out in expanded form, because we're not always going to be given numbers. Thanks to algebra, we're going to be given numbers and letters in some cases. Okay, so for example, now we have some variables in here. So we're going to write n minus 1 out in expanded form. Well, this is our n. That's the number we're given, is n minus 1. We don't know what the number is. That's n minus 1. So if we were to write that out in expanded form, we're starting with n minus 1. And then we're multiplying it by 1 less than that each time. So times n minus 2 times n minus 3. Okay, so we're, instead of starting with n this time, we're starting with n minus 1. And then we're just going to write the little ellipse here to denote that we're going to keep going until we get to a 0 or a negative integer. So that would be expanded form for n minus 1 factorial. We're starting with n minus 1, and we're multiplying it by 1 less than that until we get to 0 or our negative integers. Okay, so if we evaluate n plus 1 factorial divided by n minus 1 factorial, okay, so on top we're starting with n plus 1. And if I start with n plus 1, 1 less than n plus 1 is n. 1 less than n is n minus 1. 1 less than n minus 1 is n minus 2, and so on. And then we're dividing that off by n minus 1 factorial. So here's where lining it up comes in handy, because we're dividing it off. This time we're starting with n minus 1. 1 less than n minus 1 is n minus 2, and so on. And then just like before with our numbers, we know that n minus 1 divided by n minus 1 is going to cancel out. N minus 2 divided by n minus 2 is going to cancel out. And everything thereafter is going to cancel out. So what I'm left with is n plus 1 times n. So I have n plus 1 times n. Sometimes it'll ask you to simplify that. So n plus 1 times n is the same thing as if I distribute that n in, n squared plus n. Okay, so either of these answers would be correct. All right. So that was factorial. Moving on, we're going to talk about permutations. And what a permutation is, it's an arrangement of some or all of the objects from a set without replacement. So the important word in this case is without. So we're not replacing it. So just like that textbook that we put in our locker, once we put a book in, that was out of the mix. And then we put another book in and then another book. So ABCD is different than CBDA. Order matters. There's no repeats. You can't repeat. You can't put that same book in two different positions. Okay, so permutation, the big things you need to know is that order matters and there's no repeats. Okay, so for example, let's say you have 7 flute players in a band. How many possible ways can they be seated in a row? So just like the textbooks, player 1 could sit in the first spot. So there's 7 options for that first player to sit there. And then once they sit down, there's 6 people left to put in that second spot. Okay, and then 5 people left for the third spot. 4, 3, 2, 1. So notice this is 7 times 6 all the way down to 1, which is very similar to factorial, right? So factorial is just taking the number and multiplying it all the way down by all the products of the positive integers less than it. So there's 5,040 different ways that 7 flute players can be seated in a row. Again, that's a crazy big number. It's weird to think that there's over 5,000 different ways that 7 people can be seated in a row. We could go through and actually model this, which I've done with classes in the past before distance learning was a thing, before COVID was a thing. And, it's easy to say, okay, how many different ways can you arrange 3 different people and then 4 different people? And then all of a sudden you realize, holy cow, there's a lot of possibilities to arrange 4 and 5 different people. And then, so yeah, we wouldn't do all 7 different ways. Okay, but let's say now that we have only 4 seats available, so 4 of those lucky players in the band get to sit down, the other 3 have to stand. So if there's only 4 seats available, 1, 2, 3, 4, how many possible ways can 7 of the players sit in the 4 available seats? So there's 7 people that could sit in that first spot, or 6 people that could sit in the second, 5, and then 4, and then we would stop there because there's only 4 seats available. Okay, so we would just multiply those together, and that would give us 840 different ways. Did you pack your lunch? It's in the fridge. All right, couple more, and then we'll be done, and I'll let you work on your homework. If a 5-digit garage code is made up from numbers 0 through 9, if none of the numbers are allowed to repeat, this is a very important phrase right here. It's going to differentiate between a permutation and what we're going to learn tomorrow, a combination. There's no repeats allowed in permutations. We can't repeat any of those numbers. How many ways could you choose 5 numbers to create a code? I'm going to give you a minute and see if you can figure that out on your own. So we are picking a 5-digit code. None of the numbers can repeat. We have choices from 0 through 9. So 0 through 9 gives us 10 total choices for our first number. We're not going to repeat that. And then we're going to pick a second number. So we have 9 numbers left. We're not going to repeat that number. So then we have 8 left, and then 7, and then 6. Okay, so we have 5 places. We're going to fill in a number from 0 to 9. We're not going to repeat it. So the total possible outcomes of a 5-digit garage code with no repeats is 30,240. That would take a long time to try and hack into somebody's garage if you were just randomly trying to pick their digit code. Okay, next, there's 8 lanes on a track. If all of the lanes have runners in them, how many different ways can runners finish first, second, and third? So obviously a runner can't be in lane 1 and also lane 2. So there's no repeats happening here of runners either in the first lane or the second lane or the third lane and so on up to 8 lanes. We want to see how they can finish first, second, or third. Well, somebody's going to finish first. One of those 8 runners are going to finish first. And then one of the remaining 7 runners are going to finish second. And then one of the remaining 6 runners are going to finish third. And that's it. So there's 336 different total ways that 8 runners could finish first, second, or third in a race. Okay, and then finally, the last thing is the permutations formula. So if we don't want to write all of this out, we're going to use the formula for permutations. We're going to write 5. We're going to write this out in expanded form and we're going to evaluate. So here's the formula. You're going to want to write this down. You're going to need to know this. Okay. So permutations formula is NPR equals n factorial over n minus r factorial. So the number in front is the n and the number after is the r. Okay, so 5p3 is going to be n factorial, which is 5 factorial, over n minus r. 5 minus 3 is 2, so 2 factorial. And then remember that factorial just means that we're multiplying starting with the number all the way down to 1. We're dividing off 2 times 1. These 2 are going to cancel out. And we have 5 times 4 times 3, which is 60. Okay, 6p6 in expanded form and evaluated means we have 6 factorial. That's our n, divided by n minus r, so 6 minus r is 0. So 0 factorial is kind of its own thing. Anytime you see 0 factorial, just like if you have something raised to the 0 power, 0 factorial is 1, always. Okay, and then we have 6 factorial on top. So another thing you might want to write down, 0 factorial is always going to equal 1. And then when we evaluate that out, that's going to be 720. And then finally, 6p1. So we have 6 factorial. So 6 is our n, 1 is our r. The formula is n factorial, so 6 factorial, over n minus r factorial. N minus r is 5. If we write that all the way out, these all cancel out, and we're left with just 6. Last couple examples, and then I will let you get on your way and do your homework. These ones get a little bit bigger, and as always in algebra, we're going to throw in some variables, okay? So we're going to write 104p2 in expanded form, and we're going to evaluate it. So I'm not going to write 104 out all the way down in expanded form. Instead, what I'm going to do is I'm going to go like this. 104 times 103 times 102 times 101. I'm just going to write a few of them out, and then dot, 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 because I know I'm going to keep going all the way down until I get to 1, but I don't want to write all those numbers out. And then I'm going to divide it by n minus r. Okay, so our n is 104, our r is 2, so 104 minus 2 is 102. So I'm starting here with 102, and so on. And then I know that everything below here is going to cancel out. So what I'm left with is just 104 times 103, which is, move this down a little bit, 10,712. So don't forget to take that n minus r. So this isn't 104 factorial divided by 2 factorial. It's n factorial divided by n minus r factorial. So we have to put the 104 factorial on top, and then the 104 minus 2 factorial on bottom. Alrighty, last one. We're going to do sum with variables. We have n, p, n minus 2. So our n factorial divided by n minus r factorial. Our n is n. So we have n times n minus 1 times n minus 2 times n minus 3, and so on. And then our n minus r, where n is n, minus r, our r is n minus 2 factorial. So this gets a little bit tricky, but it helps to write it all out. So n minus r, your n is n, your r is n minus 2, so n minus 2, and we're factorialing, it's a weird word, that entire thing. Okay, so we're going to do, first we're going to distribute this in here, we're going to simplify our bottom number. So that's going to become, I'm just going to write it over here, n minus n, well that cancels out. And then n minus negative 2. So I'm not going to write these here. So n minus n, the n goes away. This is n minus negative 2. That might be an easier way to look at it. So n minus n is 0. And then we just have a 2 left. And we still have that factorial with it. So basically what I'm doing is n factorial divided by 2 factorial. So that's what I have left. So this whole thing simplifies down to n factorial over 2 factorial. 2 factorial is just 2 times 1, which is 2. So that just becomes n factorial divided by 2. That's about as complicated as you're going to see. Those ones can get a little bit tricky. We'll do more of those tomorrow, but you will see some of those on your assignment for today. Okay? So as a recap, We did fundamental counting principle. We did permutations. We did the permutations formula. We did factorial. Okay. So that's everything for today. Your assignment is in Delta Math. We're still in Unit 9, but we call this 9B because it's the second half of the unit. 9B, Day 1. Okay. So that's what you have to do for tomorrow. I will give you time to work on that. Please shoot me an email or let me know if you have any questions. Have a wonderful day, and we will see you tomorrow.